14.7 times 1, and then dividing by 2.54. Well, of course, multiplying by 1 doesn't do anything, so really we just get 14.7 divided by 2.54, and we get, of course, a weird, ugly decimal number. So now we have to figure out, well, what's the deal with the number of significant digits? We mentioned in the previous course, or the previous class, that exact numbers have no effect on the number of significant digits, so we're just going to ignore them here and just focus on my approximate number here. So I probably should have explicitly written that down here. Let me go ahead and make a comment about this. This is the approximate. Right, is an approximate number, which of course makes sense, right? There's no way that anything that's being measured by a ruler can be exactly something except for like literally the meter stick that's, you know, in some glass display case somewhere. So when we're looking at this thing, we see that it has 3 significant digits, right? And we can just ignore this part, doesn't have any effect on it because it's exact. So our answer has to be reported with 3 significant digits. So when I calculate here the 5.78, I have to round to that third position there. So that 8 is going to get rounded up because the digit after it is above 5. So we will express this as being 5.79. And of course, we're going to express this thing in inches. And you can kind of see, I like to do this sometimes, we can think about those centimeters as basically having canceled one another out. Here's another fun fact. About 5.0 liters of blood circulates in a typical adult human body, and we want to know about how many gallons is this. Well, we are told up here that 1 gallon is equivalent to 3.785 liters. So I'm going to start off with 5.0, so L is the abbreviation for liters here. We're going to take 5.0 liters, and again, multiply by the conversion factor that cancels things out appropriately. So that means I want to have liters in the bottom because I'm starting off with liters. So I'm going to put this 3.785 liters in the bottom and then 1 gallon on top. That will have the effect of canceling out my units here. Let's carry out the operation and figure out exactly what we need to do with the significant digits. For the purposes of my calculator, I don't have to write 5.0, I can just say 5. It understands those numbers the same. Oops, did that wrong. There we go. Right, I'm going to do 5 times 1 divided by 3.785. When we do that, we get this number again, a weird decimal number. This is mostly what happens when you start dividing decimals. And we need to figure out what should we report this to. Well, we started off here with 2 significant digits. And actually, you'll note, if we go back up to this thing, the conversion between gallons and liters is actually an approximate one. 1 gallon is not exactly equal to 3.785 liters. It's like roughly equal to that. So this thing has 4 significant digits. However, that one's definitely the least accurate one, right? So we are limited by the accuracy. So our result here has to be expressed with 2 significant digits. So we're going to take this number and express it with 2 significant digits. It starts with 1. The last significant digit is going to be the 10th place, and it's going to be rounded down. So that's going to be 1.3 gallons. We can also make these processes get a little bit more complicated, involving multiple steps with conversions. So one thing to know within the what's called imperial system or the US system or the customary system, which is not as good as the metric system, which we will see in the next section here. The metric system is great, but we still use the imperial or the US system for a lot of things. And one of the things that the US system specifies is that there are 16 ounces in 1 pound. So given that fact, and given these conversions that I have up here, let's put 2 and 2 together, so they say, to figure out how many grams, approximately speaking, there are in exactly 1 ounce. Well, we can think about this, again, with a sort of unit conversion process. What this would mean is we would want to figure out, I start off with 1 ounce and then use the conversions that I have to get into grams. So let's start off with 1 ounce, which for, again, complicated historical reasons is abbreviated OZ. And I want to use my conversion factors that I have to convert this into grams. Well, I start off with 1 ounce. There's 16 ounces in a pound. So if I want to convert from ounces into pounds, then ounces are going to have to go on bottom, so they cancel, and pounds, which is abbreviated LBs, also for complicated historical reasons, will go up here on top. So there's 16 ounces in a pound, so 16 ounces in 1 pound. Now this would get me into pounds, and we can observe up here that I do have a conversion that takes me between pounds and grams. So I could use that conversion factor here. And rather than doing this in 2 steps, I could set this all up as 1 step and then carry this whole thing out. So I see here that 1 pound is equal to 453.6 grams. Well, again, I have to set this up as a conversion rate. Here, since I already have pounds in the numerator, that means I want to have pounds in the denominator and grams in the numerator. Again, this is what's going to get my units to cancel out and to end up with grams as I want. Now here, in terms of what numbers go there, this is just noting here that 1 pound is equivalent to 453.6 grams. So we've got the setup here. This will tell me that 1 ounce is equivalent to some number of grams. We've got all the things canceled out as appropriate. Let's go ahead and input this stuff in here. So this is 1 times 453. Well, of course, 453.6. Multiplying by 1 has no effect. So when we multiply across that numerator, all we get is that 453.6. And then we are going to divide by 16 here. And of course, dividing by 1 also doesn't do anything. So we get, as a result there, 28.35. And now the next question we have to ask is, do we have the right number of significant digits? Can I report all of these digits as being significant? Well, to answer that question, we have to go back up to how accurate each of these numbers are and whether they are approximate versus exact. Well, the first thing we know here is that there are, by definition, exactly 16 ounces in a pound. That's how the US system works. And we are also trying to figure out how many grams there are in exactly 1 ounce. So that's exact and that's exact, which means we don't need to think about them. All we need to do is look at this one. And we do note here, this is not an exact conversion rate. Usually when you're going in between systems, you have approximate conversion factors. So this thing we can note has 4 significant digits, which means we need to report 4 significant digits in the answer. Well, it just so happened to work out such that all of these digits are significant. So we don't have to do any rounding. We can just report those 4 significant digits that we have there. So that tells me 1 ounce is equivalent to 28.35 grams. All right, so we can kind of chain these things together. And in fact, we can apply this sort of thinking to also ask a couple of slightly more complicated questions. This is one of my favorites. Something we don't think about necessarily all the time, right? Usually when we think about, say, driving a car, we tend to think about these things in terms of miles per hour. So let's say you're driving 60 miles per hour down the highway. Well, what if we think about it in a sort of more human scale? How fast are you traveling in feet per second? We're going to talk a little bit more about rates later on in this unit, but when you see that word per indicates what we call a rate, which is, again, basically just division. When you think 60 miles per hour, really what that's telling you is that you travel 60 miles over 1 hour. Right? So that is the unit that we're starting with here. The quantity that we're starting with is 60 miles per hour. And now I want to convert this thing into feet per second. Well, there's two things I'm going to have to need to convert here. One is I need to convert the length unit into feet. The other thing is I need to convert the time unit into seconds. Well, let's start with the length one because there's a straightforward way to do that, right? 1 mile is equal to exactly 5,280 feet. So we can convert between miles and feet. Again, we have miles in the numerator, in the top, so we want to cancel that out, which means we're going to put miles in the bottom, and then feet will have to go on top. So always think units first, and then figure out where the numbers go. So since 1 mile is 5,280 feet, 1 mile down there, 5,280 feet down there. This would tell me, again, at this point, the units I would have would be feet per hour, which isn't really what I want. I want feet per second. So I need to convert that time unit as well. Again, there are multiple approaches for this. You absolutely might be thinking of another way. This is just one way that I suggest because it's kind of quick and straightforward and mostly foolproof when you set it up. So if I want to convert between hours and seconds, well, I probably should throw in an intermediate unit, right? 1 hour is equivalent to 60 minutes, but I want to cancel out hours on the bottom. The way to do that would be to have hours up top, and we have hours on top and bottom of the fraction. So then hours would go on top, minutes would go on bottom. How do hours and minutes relate to one another? Well, there's 1 hour in 60 minutes, or 60 minutes in 1 hour. But again, there's 60 minutes associated with that 1 hour, so that number 60 has to go in the bottom. Conversion between minutes and seconds is going to work exactly the same, right? We want to put minutes on the top so it'll cancel, and put seconds on the bottom. And we know that there are 60 seconds in a minute, so in 1 minute there are 60 seconds. That will cancel out all of the units except the ones I want to end up with. This will happen a lot again. Some of you will be taking a course in physics at some point probably, and this is something we call dimensional analysis, thinking about the units involved here and making sure that they're doing what we want. Having set this all up correctly, now we can go ahead and just, again, use our calculator to figure out what this is going to simplify to be. So I've got 60 times 5,280 times 1 over 60, which would really be like dividing by 60, and then dividing by 60 again. Now I could type all this stuff in my calculator, and that's totally fine, but actually, I'm going to be clever about it and observe that the 60, when we divide 60 by 60, it'll just be 1. So we can kind of save ourselves a little bit of time and divide that out before plugging it into the calculator. But if we go ahead and carry this operation out, 5,280 divided by 60, right? Note all of the multiplying by 1, dividing by 1 doesn't do anything, so I'm not going to input it into my calculator, save myself a little bit of time. So we get a number of 88 feet per second, which for some reason always sounds faster to me than 60 miles an hour, right? We're so used to like driving 60 miles an hour like it's no thing. But when we're driving 60 miles an hour, we were traveling at 88 feet every single second, so you cover a football field in like 3.5 seconds or something like that. One last thing we want to explore here, which is making these things a little bit more complicated here, and think about what happens when I have squared kilometers or square miles, and if I want to convert from one into another. And basically what we need to do is, when there's some sort of computational operation carried on a quantity with units, we also carry this operation out with the units themselves. So let me talk about this in a couple of different ways. The first way is to think about it geometrically, something we'll do more in the next chapter. But let's imagine, what's the relationship here between square kilometers and square miles? Well, from last page here, we have that 1 kilometer is approximately equal to 0.6214 miles. So imagine we had a square kilometer, right? Literally a square kilometer means a square that measures 1 kilometer by 1 kilometer. If we ask ourselves how many square miles are in this 1 square kilometer, well, we would have to think about both units as being in terms of miles. Well, we just said 1 kilometer is about equal to 0.6214 miles. So this thing would measure 0.6214 miles, and then this dimension would measure 0.6214 miles. As we'll talk about more in the next chapter, area of a square is simply length times itself. So this thing would be equal to 1 kilometer times 1 kilometer, which one way of writing it, so instead of writing it as square kilometers, or in the last section we abbreviated it as SQ, another way to write this would be kilometers squared. So you can put that square in front of that, or sorry, at the end, and treat it like an exponent. Kilometer squared means kilometers times kilometers. So what would this be equivalent to? Well, we'd have to think about the 0.64 miles times 0.64 miles. So when we're thinking about converting this square kilometers into square miles, one way we could set this up would be to think about this as 98.5 kilometers squared. And we're going to need to convert both length and height of this into miles. So we're going to multiply by the conversion factor of let me use the numbers that I have here, 0.6214 miles per 1 kilometer. But then I'd have to do this twice. 0.6214 miles per 1 kilometer, right? If I did this, again, kilometer squared, meaning kilometer times kilometer, those would cancel one another out, and we would be left with miles squared as a result. So again, note, we have to multiply by that factor actually twice in this case. So 98.5 times 0.6214. Well, note that we're multiplying by it twice, so why don't we be clever about it? Multiply by that thing squared, save ourselves a little bit of time. And what will we get? We will get 38.0. Well, the last thing is we need to report this result with the appropriate number of significant figures here, or significant digits. Because my conversion here, note, it is not an exact conversion, so we do need to think about the fact that this 0.6214 does have some amount of error to it. So that is going to limit the accuracy of my result. I've got 3 significant digits here. I've got 4 significant digits here. We use the accuracy of the least accurate result, so our result is going to have to be 3 significant digits. So that means we're going to have to round to this third digit, so the 3 and then the 8 and then the 0 is going to have to get rounded. Since 3 is less than 5, thing's going to get rounded down. So this one will be given as 38.0. We will include that 0.0 to indicate it is significant, and that would be miles squared. All right, that is all we have for today. We will continue on with this sort of theme in section 1.5. Have a wonderful day.